right, so this is video number 2, and so now we're going to take our next step out. We're going to go to the next step number 2, which we'll get into here in the next slide, but we're going to talk about the horizontal asymptote. Okay? So a couple of things about the horizontal asymptote. First off, just like a vertical asymptote, it is a line, and so therefore it will need to be in the form of y equals some number, because all horizontal lines are in the form of y equals some number. Okay? It will be, when we get to the graph tomorrow, it will be dashed on our graph. Okay, we'll talk about that tomorrow. It's got to be on the graph. We'll talk about that tomorrow. Okay? And the difference is that you can have as many vertical asymptotes as your denominator allows, but here you can either have one or none. You can't have two horizontal asymptotes. You can only have one. Most of the time, you'll have one. Sometimes you'll have none. Okay? Just so you are aware, it's tied in with, or it goes along with, end behavior. So when I'm asking you to figure out what the end behavior is, so it's going to be, so like if I would draw out an end behavior as x approaches positive infinity, f of x approaches this number right here, that when we fill in that box, that's going to be this number right there. Okay? So the number that we approach on the left and the right side of the graph, the functions are going to end at their horizontal asymptotes. Okay? So how we go about finding the horizontal asymptote is, and this can now go on your extra sheet. Okay? So we're still going to leave space for 0. Okay? Step number 1 was find the domain in any vertical asymptote. We did that on Monday. So now here is the steps to finding our horizontal asymptote. So what we're going to do is we are going to compare the degrees. You're going to compare the degrees of the top and the bottom. So in our function, we're going to look at that number, and we're going to look at that number. We're going to compare those two numbers. Okay? So if the bigger or the bigger degree is on top, okay, and the smaller degree is on the bottom, we have no horizontal asymptote. An example of this would be something like f of x equals x squared plus 4 all over x minus 3. The degree of the top is 2. The degree of the bottom is 1. So it's 2 over 1. The bigger number is on top, smaller number is on the bottom. No horizontal asymptote. Okay? If that's reversed, if the smaller degree, is on top, and the bigger degree is on the bottom, then we get y equals 0 is our horizontal axis, horizontal asymptote, which is the x-axis. So this example would be f of x equals x over x squared minus 25. I think that was one of the examples you did in the last video. So there's that one. Degree of 1 on the top, degree of 2 on the bottom. Small over big, horizontal axis, y equals 0. Okay? Now, if those degrees, if the biggest exponent are the same, then we compare these two numbers right here, A and B. That's where we get the A and B from. And our horizontal asymptote then is y equals A divided by B. So for instance, this would be something like f of x equals 3x minus 7 all over x plus 2. In that case, both the top degree is 1, the bottom degree is 1, same. So then I look at my A and my B. This just happens to be 1 there. So it's y equals, so the horizontal asymptote here would be y equals 3 over 1, or just y equals 3. Okay? Take a moment to pause the video. Make sure this goes down on step number 2 on your supplemental note sheet. Now that you've got that written down on your supplemental note sheet, let's talk about this one. So on this one, I want to find the domain of each of these two functions, and I want to identify any horizontal and vertical asymptotes. I'm going to do the left one, you're going to do the right one, and pause the video, do the right one, and then come back and check your answers. Okay? So first off, step number 1 on our extra note sheet says to find the domain, we take the denominator and we set it equal to 0. Solve it. And that gives us our restrictions in our domain. So the domain here is all real numbers, but x cannot be equal to -1, which means then that x equals -1 is my vertical asymptote. Now, for my horizontal asymptote, I compare the degrees. So the degree of the top is 2. The degree of the bottom is 1. So I have big over small. And when we have a big over a small case, that's a none horizontal asymptote. I'll go back here a slide. That is a big over small horizontal asymptote. There isn't. Oops, hold on. There we go. So there, and I would write none. I can't write y equals 0 there because y equals 0 would be an actual horizontal asymptote. So I write none. Okay? With that being said, you try number 2 now. Just find me the domain, the vertical and the horizontal asymptotes, and then pause the video, and then once you replay the video, I'll have the answers posted for you. So here's the answers to number 2. So you should have found that the domain is all real numbers with the exception of x cannot be positive or -3, which means then we have vertical asymptotes at x equals 3 and x equals -3. Remember from the first video, those need to be separated out. We can write them as plus or minus in the domain, that's fine, but when it comes to vertical asymptotes, those need to be separated out. Okay? And then since the degree of the top was 2 and the degree of the bottom was 2, that's the same, 2 is equal to 2, so then we're looking at A over B. A on top, the lead coefficient is 6. B is on the bottom, the lead coefficient is 1. 6 over 1 is 6. So the horizontal asymptote is y equals 6. All right, so on this one, we need to find the domain, identify any and all asymptotes, and then find the end behavior and the asymptote behavior. All in one problem. All good things happening. Okay? So first off, we need to, in order to find the domain, step number 1 says we set the denominator equal to 0 and solve it. First thing I would do is I would cube root both sides. Cube root of the left side is just x minus 2. Cube root of the right side is 0. Add 2 to both sides, x equals 2. So the domain of my function is all real numbers, but x cannot equal 2, which means I have a vertical asymptote at x equals 2. The degree of the top is 1. The degree of the bottom is 3. So that is small over big. And in that case, that was a y equals 0 for our horizontal asymptote. Now we just have end and asymptote behavior. So let's talk asymptote behavior first. So we're going to say as x approaches 2 from the left, my function approaches something, and as x approaches 2 from the right, my function approaches something. Okay? So let's look at 2 here now. So if I go 1.9 on the left, I plug that in, so I'd have 4 times 1.9 divided by 1.9 minus 2, then cubed. So 4 times 1.9 is 7.6. 1.9 minus 2 is 0.1. 0.1 cubed is 0.001. So that's going to be positive. Excuse me. This would be negative 0.1. So that cube would be a negative 0.001. So as I get closer and closer and closer to 2, this number down here and this number down here are going to be smaller and smaller and smaller, but always be negative. So I got a positive number divided by a really small negative number. That's going to go to negative infinity on the left side of 2. On the right side of 2, if I do 2.1, I'd have 4 times 2.1 divided by 2.1 minus 2, then cubed. 4 times 2.1 is going to be 8.4 divided by, now positive 0.1 cubed would be positive 0.01. Again, now I've got a positive divided by a positive, so that's going to go to positive infinity as this number gets smaller and smaller and smaller and smaller, because we get closer and closer and closer to 2 on the right. Okay. Then one last thing is end behavior now. And the nice thing about end behavior is we can say as x goes to positive infinity, my function is now going to go to this value right here, the whatever the digit is in the horizontal asymptote, that's what it's going to go to. In this case, it's 0, so it's going to go to 0. As x approaches negative infinity, our function can go to 0. We just have to figure out above or below. So if let me erase this here. So now if I think about this in terms of if x is a ginormous number like 1 million, I've been kind of hitting on the 1 million. So on top I've got 4 million. On the bottom I've got 999,990 cubed, which is a ginormous number. 999,998 times itself is a big number. But it's going to be a positive divided by a positive. So that's going to go to 0 from above because they're both positive. If I flip that around and now I go with x is negative 1 million, I would have negative 4 million on top, and I would have negative 1,000,002 cubed on the bottom. Top's going to be a negative number because negative 4 million is negative. The bottom, a negative times a negative times a negative is also negative, and a negative divided by a negative is positive. So they're both going to approach 0 from above on both sides of the graph. And that's fine. We have to do that logic to prove that out. Okay? You now have enough information to get through number 3 on the worksheet. So you should be through by the end of class today, or by the time you show up to class tomorrow on Thursday, you should have numbers 1, 2, and 3 done on the worksheet.